Whenever I find myself feeling uninspired or experiencing crushing existential dread, I have a simple recipe that lifts my spirits. Number 1, pick a thing. Number 2, set it on fire. Let's set this dumpster on fire. The first thing we're going to do here is import the dumpster model. I got this on TurboSquid, it was free, and all I'm doing here is just transforming the scale to 0.01 to match the world scale, and I split off the lid, just selecting that geometry. So I had the dumpster on its own and the lid with a pivot transform so that I could move it around if I wanted to. Second thing we do is we make a collider. So this dumpster is a really simple geometry if you think about it as a collider. It's just a box. So all we really need to do is make a box around this thing, and I'll template this so you can see it. Just make a box, we edit it, bring this one edge down so it tilts, we extrude it, we bring it down, and then I just dragged it down and sort of recentered it, something really simple like this. And then the important part is that we have a geo coming out to use as the geo side of the collider, and on this side we VDB from polygons it and use a pretty small voxel size just to make sure that there's no holes or anything like that. Once we have the collider all set up, we can start on this sim. And the first thing we're going to do is create a source for the fire. I did 2 separate sims here, one for the fire and one for the smoke. And that's because I wanted kind of a specific look for the fire and a specific look for the smoke. And when I tried to do them both together, it didn't really look good because I needed more control over each of them individually. So all we're doing in here is bringing in our dumpster model, and we are cleaning it up. We're removing attributes here, some stuff from the FBX rotation. We don't want that. We're not using this in a render, so we're gonna get rid of like name and material path, alpha, color, all that stuff. We don't want that. And then we're just gonna give it a quick point normal here so that we know we have that data to work with. And I'm just selecting this area on the top here. There's a little mesh in here that has like a trash texture applied to it. So that's what I'm going to use for the base of our fire source. And splitting that off and then just kind of extruding this in just a little bit. There's a bit of an inset here just because we don't want the edge of the source to like intersect with the collider. It'll work itself out eventually, but it's just a problem we can solve here. And then we're going to scatter some points on here. And from those points, we're going to add an emission attribute. And so that's basically just, we're going to call this emission and we're going to set it. It's going to be a positive number, and we're going to use this ramp to sort of control. If I visualize this here, the noise is fairly high contrast here, as in, you know, where there's some hard edges between these, and that's because I want to shape these flames to be pretty jagged and sharp and you know, make sure there's definition in the burn pattern. And then I'm actually taking out points that are super low emission because those are still going to produce density. In this case, for the emission, we're going to use that as density. And so I just really wanted to break this up and make it sharp, so I ended up taking out densities here, and that's just a simple if statement in Vex. If the emission is lower than that, then just remove that point. And then we're going to add a p-scale variable. At p-scale is a value that is prolific throughout Houdini, used for scaling points, and that's going to control our particle size. And all we're doing here is p-scale equals 1 times emission times this ramp, and then times the scale here. This is sort of a global scale parameter, right? And so that's going to allow us to shape this, you know, from low emission to high emission. We control how that falls off, so we get a bigger scale for bigger emission. That's all that does. Next, we're going to animate that variable because we want these layers of change and noise and stuff to make this look really organic and broken up. So for animating the scale parameter, I've got a point VOP, and if we dive in there, this is very simple. We're just taking the position, we're piping it into a turbulent noise. I use sparse convolution, 1D noise because we're affecting a float here. And anything in green here is stuff I promoted to a variable so I could access it at the top level. So that's these fields, right? And we need to do that to add time with an expression. And to add any of these as an attribute at the top level, a parameter, you just middle click and do promote parameter there, and that'll do that. So next we are multiplying this by a constant, and I guess I could have added that to the top level as well, but that's basically just scaling this noise. And we're bringing in the p-scale with a bind node, that's bind, and then we just need to name the variable as p-scale. We're going to add that noise to the p-scale, so we're sort of like making that bigger and smaller a little bit, and then we're just going to fit that value between 0 and 1. Then we do a bind export, which is the other bind node, bind export. Make sure to name this p-scale, spell it correctly, and it's a float. So that's going to give the result of that set back to that p-scale variable. Next, what we're going to do is animate the normals. So if I look at the normals here, they're just based off of where the polygons were on the geometry when we scattered the points. And we want those to move a little bit. And if I play this, you can see those sort of flickering there. And what we're basically doing is getting up to this point where we add a line and copy it to points, which is we're gonna start making things that look like flames. They're just gonna be these little lines that sort of look like flickering flames. And so this is kind of the first step, right? So in the animate normals, this is a point VOP as well. We had a curl noise, this time a 3D noise, and it's purlin in this case, to promote a couple of parameters to make our lives easier. And then we're going to fit this, again, between 0 and 1, and we're going to add that to the normals, which we drag out of here. So that will become our new normal, and that will animate over time. Once we're done there, we can copy a line, just a simple line. It's going to be of length 1, points 2, and we want that to go into a resample, and that's just going to give us more points. And we're also going to set our curve U attribute here, which is very, very important. We're going to use that in the next step. So all we're doing here is copying that to points. So now we have those variables, the P scale and everything, the normals moving around layered into this. But now we have more points. We have, as you saw there, we have a lot more points in our geometry. So that means we can make some finer movement details in here and kind of like chop them up and make them a little jagged, make them look like flames. And so I'm going to add another point VOP in here. And this is going to control that animation. If I play, you look closely, you can sort of see those lines get, turned around and a little bit nastier here. So that's going to animate the position of each point on this line as they play. And to do that, we're just going in here, similar pattern, right? We are going to take the point attribute, we're going to put it into a flow noise. We're going to use this curve U value here to attenuate the noise. So what this does here is we take our curve U in a bind node, we ramp it so that we can control where we want this to have, we're going to remap this to be not exactly linear 0 to 1. There's sort of a cutoff point here now as I've shaped the curve, and we're going to multiply that with the noise so that the noise affects only things at the top of the curve instead of the base, because we want the base to kind of stay strapped to that normal that it's copied to. And here I've done a fit between negative 0.5 and 0.5 because this particular noise is actually generating negative 0.5 to 5 values, and we would like that to be 0 to 1 because that's what we want to multiply our curve U value by. And so finally we multiply those together, we multiply them by a constant, and then for some reason do that again, and then we add that to the point value, which is going to make our points move, the position value, which will make the points move. And then we put that into the P attribute, and that becomes our animated position attribute, which all of those points are going to follow. Now that we've got these points moving in space, we're going to add a velocity value because that's going to give us, in basic here, we're just going to do backward difference for this. And I'm just adding a little bit of curl noise to that velocity to give it some more interest. And so those moving points are going to give us an attribute called V, which we can now see in the points. And we're definitely going to use that in our sim. So that's kind of our basic fire point system. And now we've got to convert this into data that can be used by Pyro and add a few more attributes that are going to be used in the sim as well. So to do that, we're first going to add a Pyro source node, and this is going to be where we start sourcing our attributes for the sim. And all we're doing here is saying the particle separation is fairly low, again, because this is kind of small. We need to kind of give it, a good bit of resolution, and that's not going to cost us too much. And then we're going to add 2 attributes. When you add this node, when you add a Pyro source node, there's going to be nothing here, but what I did was just add 2 attributes, and then I changed this to burn, and this one to temperature. And that's going to give me these values that the sim needs to make fire, amongst a few other things. We'll talk about that in a second. And so those are sourced here. Their default value is 1. And so now we're going to add some noise to those things. So first we're going to take burn, and we're going to do an attribute noise float. We're going to basically just multiply this by a positive number so that we're getting things that are varying that value of 1 we set. Relatively small element size. I did a remap ramp here, so you can just enable this. So again, we can kind of control where this cuts off and how it affects everything going up. And then I'm going to also use that burn or that emission value to control my temperature. And then we're going to noise that temperature. Again, remapping, same kind of stuff, right? Over and over and over again. That's animated. The pulse duration is 1, which is is kind of slower. And then I did that again, and I have to assume that the reason I did that was to have 2 noises operating on temperature, one controlling sort of the upper range here, and the other one a bit lower, a bit slower, or a bit faster. And this one's element size is bigger. So you've got these 2 sort of like temperature gradients moving across in sort of this parallax movement where everything is offset and just makes it look cooler. So finally, when we have all those values, we want to then rasterize them. And we're going to specify that we want to source the burn, the V, and the temperature. The voxel size I have as a channel parameter from the sim, which we'll go over in a second. And you can see that that's, it's a 3D shape. It's not just sitting on the surface because we have these little flames that we made out of geometry. So one way to do Pyro sims, I like it. There are many ways to do everything in Houdini. And before we go in the sim, I cached this. So this is just a basic BGO cache, all frames, and so we have faster loading and everything once we go into the sim. So let's dive into this fire sim. To create the fire sim, we're first going to need to set up a DOP network, and you can just do DOP and DOP network. And when you jump inside this, you're only going to see an output node. So I will go into the one that I created and show you what this looks like. Diving into this DOP network, there are 3 important things that we need to set up to get this started. One is a Pyro solver. I'm using the regular one. There's also a sparse one, which you can experiment with. I'm just using the Pyro solver regular. We have a smoke object, which there's nothing really interesting happening here, except I'm closing the -y so that nothing really escapes the bottom. And I'm also being conscious of what the size of this is going to be. So this doesn't need to be very big because the camera is sort of cutting off, pretty low. And then I just wanted to give it a little bit of an extension to the right so that all of that smoke would go out. And it doesn't really touch the wall in the final render. So I don't have a collider set up here or anything like that. But that's just the size. So I'm sort of scaling that down only as much as I need it for the final shot. We also need a volume source node here. And we are going to hook that up to the first context geometry if we have our source data put into there, which we do here. And we are going to source some stuff from that source. And so we're going to hit the plus button 4 times, and you can just fill these in, right? So the first one, we're going to take that temperature value and we're going to turn it into density because we need something here to create volume for the flames. And so we're not creating smoke here, we're just creating fire. So we're just going to take the temperature, which is obviously where fire occurs, and we're going to pump it into that density field, and we're going to give it a pretty small scale. So we're basically just backing that density off enough so that we have something there, and we're just going to add that in. The operation is add. Next, we're going to take that burn value and turn it into flame. We're going to bump that up a little bit and take the maximum. And then we're going to take temperature, which is just as is. It knows that this is temperature. And we're going to bump that up quite a bit. Temperature is super important in these sims. It has a lot of impact on what the speed of the fire is, how big it gets, how long the flames burn, all that kind of stuff. So you want to kind of mess with values here. So I ended up bumping this up quite a bit. I gave it a pull operation, and I turned up the acceleration strength quite a bit to get it to kind of be a little violent, not too bad. And then finally, I'm adding from our point velocity node, we got V, but we need to tell it that that's vel because that's what the sim's looking for velocity, and then the operation there is add. Over here, we have the colliders, and sometimes on smaller sims, I find that I start with this approach because I want to solve my problem in the beginning and not the end, where I will do the geometry collider and the volume collider, the SDF, as separate static objects, merge them together. You have good luck with this stuff with like small fluid sims and glasses and stuff. This can really help when you got things falling through the collider. So I just set it up like this. Not sure I actually had to do that, but it didn't seem to slow anything down, and it worked, so I kept it there. So we're bringing in a static object node. We're going to just paste the value. You can go over here to the colliders, wherever those have escaped to, and you can just copy. If you highlight a node, you can do Control-C, and then we can go back into our sim and just paste this in this value here. So a real easy way to assign SOP paths. And from here, we're going to set this thing, which is usually solver default, to use surface collisions. And that's going to tell this thing to just use the geometry on this one. And then I just copied that over, and instead of doing surface collisions, everything's the same here. I just did use volume collisions. And then we set this to volume sample max axis. You can also do by size, works sometimes, but again, this just worked. And in here, we need to paste that other one. That's the SOP path of that SDF one where we did the VDB to polygons to get us that. And if you want, you can look at those and just make sure your collider is all working. And that looks fine to me. Turn this off when you're running the sim. For some reason, that makes it way slower. And speaking of which, let's talk about how we set up this Pyro solver. So I'm going to start sort of from the right here because this is sort of a global setup for this solver. So turn on OpenCL if you have the ability to do that. This is going to run the sim. This is a very simple explanation. It's going to run the sim on your GPU instead of swapping between CPU and GPU, which is slower. For these advection methods, I usually find that these BFECC ones just look a little better for advection and velocity advection. And then for the advection method, I usually use trace RK3, which again, small differences, but it does add up. We're also going to talk about some other performance enhancements we can make here in a minute, but let's go to the shape, which is the fun stuff. So I'm using a couple of these shaping things: dissipation, disturbance, shredding, and turbulence. Dissipation is basically just going to control how fast things disappear, right? So this is going to have effect on how long the flames live, all that kind of stuff. Disturbance is a really good one. Let's talk about turbulence first. So turbulence is kind of like the big noise, right? And this is going to give us a nice variation starting off to get rid of those mushrooms and big plumes that sort of stick together and don't look like fire at all. This is a fairly small swirl size, again, kind of, relative to the size of the sim. And I did here what's called adding a control field. And this is just saying use temperature to sort of drive what this is doing, right? The weight of the turbulence, basically. And I'm setting this control influence to be fairly high because I do want this to kind of listen to this, and I hit remap control field. So basically what this is saying is where the temperature is low, don't give it that much turbulence, and as the temperature rises, do apply more turbulence. And so that's kind of a nice way to add some variation and some realism to these things, is to use a control field with one of those values that you've got imported from your source and sort of drive these things that way. So this is kind of the coarse adjustment of noise, and things like shredding and disturbance are sort of the fine adjustment. So if we move over to disturbance is a thing that basically adds crunchiness to the edge of your flames, right? Or smoke or whatever. Where that interacts with air, it's going to add some velocity noise and give you even more breakup on those mushroomy shapes that you don't want. So the important things here are block size, and hopefully I'm showing a graphic over this which actually shows the visualization of disturbance. But this is going to be basically how big the area that the velocity voxels are around the outside edge of your sim. And so what this does is basically you want a smaller value for finer disturbance, and in a smaller sim you want to make sure that that isn't very big. This worked for me. I didn't do any remapping here. There's some good stuff you can do with like remapping this with a speed value, so that when the flames are really moving, they're getting disturbed a lot, and when they slow down, they don't. I found that I didn't really need that. That helps more for sims that are kind of bigger, and this was just the fire, so I didn't really think too much about that. For shredding, this is going to give us even more sort of fine control. This is sort of the flames kind of tearing apart. We want that. We want to rip these things apart a little bit to make this interesting. And so I once again added a control field of temperature here. That's basically when the temperature is low. So, kind of at the top of the flames, we want to rip it apart a good bit. And that gave me sort of that flickery effect where there's little pieces kind of cutting off and making that really nasty kind of look there. So when the temperature is low, we want to give it a lot of shredding, and then when it's high, we don't. And so that middle value is going to make sure that everything does get a little bit of shredding, except where the temperature is the highest, because I kind of wanted that to, where at the bottom, basically, like give it, a good bit of good volume to work with there. So that's pretty much everything in this solver. On the simulation side, I basically, temperature diffusion at 0 was necessary for this because that's going to blur the temperature value. And so I wanted this to be very sharp. It's a smaller sim, so I set that to 0, and that looked fine. Cooling rate is set fairly high because I wanted these flames to kind of like cool off, pretty fast and not get super huge, because that scale just doesn't match sort of the real world size of any of this stuff. I also have some microsolvers up here. These guys are called microsolvers, and you got to make sure to plug those, or at least these ones, into the velocity update. And I have a wind here, which is very simple. And the only reason I do this is because when you see a fire in the world, it tends not to just go straight up, right? There's always some kind of little ambient movement of air that's going to push this somewhere. So that just sells it a little bit better, has a little bit of realism. And in the final shot, there's that break between the buildings. So I figured, okay, there's probably some ambient flow coming in there. Maybe that's what's going to give us just that little bit there. And gas vortex confinement is a great node to use on stuff that has little kind of vortices and detail, and that's just going to help sell that a little more. I bumped the scale down just a little bit again because the sim is a smaller scale sim. And one thing that you can try is, like, if you have this set to OpenCL and it works great, and then you add a microsolver and it starts to slow down drastically, most of these microsolvers have their own use OpenCL thing. So like if I did that disturbance, gas disturb, as a microsolver instead of in the Pyro solver, I would want to go to advanced and make sure that I had checked this on, or else that won't use OpenCL and it will slow things down. So pay attention to that. But these, I believe you can also do these in the Pyro solver. They've added this confinement thing here, which is pretty much exactly the same thing. So you can kind of do all that in here, but this is sort of old habits die hard, putting some of these things out here. And let's talk about a few other things we can do to sort of make this look more interesting and give us some performance enhancements here. So out of this fire simulation, I want to import some fields to finally sort of visualize this. So I'm going to drag this into here. So that's the DOP network. And then we want to use the smoke object, which is our data, as the DOP node. And from that data, we're going to import 3 fields. One, we're going to do density, we're going to do velocity, and we're going to do temperature. Velocity is important once we go to render this, because if we want motion blur on this fire, we need to give KarmaXPU a velocity value so that it can actually compute that. And then density is important for seeing it, and temperature is obviously important for other things like color and all that stuff. This is a Pyro post-process node, which helps a ton. So what this does is if we middle mouse over this, you can see that there's this 5 grid volumes, right? And this is incredibly inefficient. There's like 21 million voxels. This is also the render res. So the 21 million voxels is a lot. It also has 3 different volumes for velocity. We don't want that. What this does is, if we look here, we have these 21 million voxels. The first thing we want to do is check on convert to VDB, and that brings us down to 6 million, on the top one we were just looking at, which is great. And then we want to combine the volumes, which is going to take that velocity volume, instead of having a separate velocity volume for X, Y, and Z, it's just going to collapse that down into one for vel. And then we want to convert to 16-bit float to make this smaller on disk. And we can also resample the velocity volume, and that's because we're not really getting detail from that. We're just getting, kind of moving for advection and stuff. So it doesn't need to be as high res, so we can downscale that, and that's going to make this sim a lot smaller. Next, we're going to cache it once we have all those things done. And then finally, on the output here, I've got this set up just so I can do a little bit of an initial look dev. Not too much interesting going on here. We've got smoke turned off, we got fire turned on. This intensity scale is relatively high, but this is not like the hottest fire, so it's kind of parked in the middle there. And then also with this, to get those flames to look, very separated, you're going to want to mess with this. That's a wide mask center, and this is sort of, we're starting to see those shreds and the disturbance and the space between the flames. This doesn't do anything in render, but this is going to give you an idea of where you should start setting your shader values once we get to the actual rendering. And then over here, I've also just exported this to USD. This is a simple USD export node, just saving this to USD in wherever you want, because we're going to bring that into Solaris as a USD. So that's sort of the performance stuff I was talking about. And if you set your view flag to here, your render flag to here, and you hit this pin, when you go inside when you go back, let's say, to make some changes here or something, this is going to be faster, even though it's like quite huge here, because this is fairly high res. So now let's talk about the smoke sim. For the smoke source, this is going to look a lot like the flame source. So we're taking our dumpster, we're deleting those attributes, we're adding point normals, and we're just grouping this trash again, splitting it off, poly extrude, inset it a little bit, scatter. Difference here is we're going to start initializing different values. So instead of burn and stuff, we're going to do density. And so this density is for the smoke sim, right? So, and this is going to be, these values are a little bit softer. We don't want to break up that density as much. The smoke can be more billowy, right? And that's why we're doing this, so we get different shapes. Now I'm setting the P scale. You could do this with an attribute create. I kind of prefer to work in Vex sometimes just because it's easier to think about for me. But all this is doing is just saying, scale this. This is just a global scale of the P scale for these points. We are then going to rasterize those. Just here we're going to do density alone, and that's it. That's all we're going to rasterize here. But we are going to combine this volume with another one. And we are going to take the fire sim out. We are going to delete stuff that we don't need, and we are going to blast out anything that is not temperature and velocity. So we're going to have those left over because we want those in this volume here that goes into our sim, because we want to transfer that volume and temperature over to the smoke. So these things are not happening independently. The smoke is being driven by the temperature from the fire and also the velocity. So they are separate objects, but they are controlled, sort of by the same stuff. So let's dive into the smoke sim here. It's another DOP network, and this one is very similar to the fire. We've got our smoke object, and I just copied this from the volume that surrounds the fire sim, and we can just right click and do copy parameter from the fire sim, and then just do paste relative references into those fields that you want to reference. So that's set up for us. The volume source here, we're going to source density. Same thing, we're going to do first context geometry, sourcing density, temperature, and vel. And you can see that what I'm really concentrating here on is density, where I set that to be fairly low in the fire sim. I'm keeping this at 1. And instead, I'm going to back off the temperature and the velocity a little bit. I did use the add value with temperature because it just made it so fast. If we use that pull methodology, the acceleration is just like way too much. and velocity we just want a little bit. So these are coming off that fire sim, and that's what's gonna unify all this stuff. In the Pyro solver, we have the same sort of stuff here. We are doing dissipation, and because this is smoke, this is kind of like billowy, gross, greasy garbage smoke. We want it to dissipate a little bit more slowly, so that's gonna be lower than the fire sim. And we're doing the same sort of stuff. We're adding that disturbance. This time I'm using density, just to sort of give it where the density is lower. We're gonna have higher disturbance, so when it kind of fans out, we're gonna see a little bit more crunch on the edges. And then as the density gets higher, we'll do that a little bit less, and sort of let the turbulence take over with those higher densities. I did not set a control, or I did. I set a control thing on this. It's also going to be density, so that when we have low density, we're getting pushed around more by the disturbance, and when we have higher density, we're getting that larger, larger sort of coarse adjustment from the density on the turbulence. Again, set this to the same settings, BFECC and TraceRK3, use OpenCL, and this is all pretty much the same. This was just copy and pasted from the fire sim because we're using the same collider, and I copy and pasted these as well, just because we want the wind to be the same and all that. And so that just merges out and goes out to our optimization stuff, which is also the same. So we are DOP importing fields, density, and velocity here, because again, we need that velocity for Karma. This isn't really doing anything except going to Karma and telling it to use it in computing motion blur. Same deal on the Pyro post process here, and then we cache it out. And we do a little Pyro bake volume, which is, this is looking cool. And again, we're turning off fire here, we're just having smoke, and, just messing with this stuff, getting an idea of where we're gonna need to put our shader values out when we actually go render this out. And finally, also caching this to USD exactly the same way we did with the fire. All right, let's jump over to Solaris here and talk about how we render this out. So this scene is kind of a misdemeanor here, so I'm just going to focus on the parts that matter, which is our fire sim and our smoke sim. The rest of the stuff is done, basically, these are all static objects, just brought in with Component Builder. I did go over Component Builder in, I think, my last water video, so if you have questions about that, you can take a look at that. And so if we concentrate here on the fire sim and the smoke sim, these are just reference nodes that we're bringing in that USD that we cached out there for the fire sim, we're bringing the smoke in same way, and we are going to set a render geometry settings on the fire. We scroll down here and go treat as light source, yes, because we obviously want that fire to light stuff up. And let's look at the shaders. So inside this material library, we have a fire shader and a smoke shader, and so these are going to be just your pyro shaders, right? This is a Karma pyro shader, which if you go up here, you just do Karma and pyro material, and that's what this is created from. And so on the fire shader, we've got enable fire. We don't want smoke on. And I set the intensity scale quite a bit higher here because it looked better in the scene, and I wanted some more light thrown around. And this basically just, if you move this up in the fire intensity ramp, it's basically just going to give us that little more definition where those things that are a little bit less hot aren't going to show fire. So we get a little bit more definition in the fire. I just used this color ramp. I thought it looked fine. And again, I enabled that mask and based these values on what I had set up in that Pyro bake source node. And so that's really it for this. That's the shader for fire. And then the shader for smoke is also pretty simple. This is another Pyro shader. And instead of, we turned off fire here and we've got our smoke on. And so the density is relatively high. The color is sort of close to black, and the shadow density, which is sort of how, that kind of like inner shadow, that makes smoke darker, just naturally how light passes through it. That's gonna increase that effect. And nothing else really crazy changed there. That's all for those shaders. For lighting here, I used 5 different lights. And for the first couple, I basically just brought in a texture from Google Images that was like a city. And so I added that to the area lights because that just gives you a little bit more interest than a solid color. You can't really see all the colors, distinctly once they're shining on a surface, but it just gives it a little bit more intrigue. And so that's just an area light with that applied, exposure fairly high, because that's sort of out in the background. And that's this one, kind of pointing in this way. The other one is another city light that has sort of a more blue texture to it. Again, just a screenshot, just cooler tones. I kind of wanted that yellow, blue, teal, orange classic look thing going on here. So I just blasted a little bit of blue light at the edge of the dumpster to get sort of a highlight, almost like a fill light or something like that. And again, that's just sort of, exposure fairly high with the texture on it. For all these lights, in the Karma tab, I have the light path expression turned on, and we're going to talk about that when we get to render settings, but that means we can split out the effects of all these lights and kind of build a composite from that, so we have a lot of control over how we adjust those things. I added another one of those back here just to sort of give this there's something up here. It's a restaurant sign or some annoying ambient light in the city that's just basically acting as a rim light of sorts here to give the back a little bit of interest. And then the street light is kind of the main light in the scene. That's up here on the telephone pole. And that's basically just providing this pool of light to really highlight the dumpster and give the foreground some contrast where there's light here and it's darker here. And on this one, I've used the shaping tab here to turn it into a spotlight and set that angle so that it is really doing the spotlight thing. And then all of this barn door shaping is basically just to really fine tune where that pool of light begins and ends around the dumpster. So you can play with that a lot. These are really great parameters to mess with. And finally, we've got an HDRI, again, tagged with that LPE tag. OS just means that it's going to be whatever this name is going to be the prefix for that LPE tag. And that's my sort of yellowy city light. This is just a free HDRI I got from HDRI Haven. For the camera, not too much interesting stuff here. This is a real world scale scene, so I can use kind of the values you'd expect. I give it a relatively low f-stop just to get a nice depth of field. My focus distance is set exactly on the sort of center of where the fire is. And I did add a little bit of noise to the translation here to get like a camera shake effect. And if you want to do that, you can just right click on the field you want to put that noise on, go to motion effect, and go to noise. And that will give you a little chop network here. You can go in here and add the noise parameter here. This is very, very subtle, but it's just to sort of give it that little handheld feel-ish. And that's pretty much it. I just went with a 239 render because I like the way that looks. And that's pretty much it for the camera. So let's talk about these render settings a little bit. We're obviously on XPU here. In the basic tab here, we just have, again, these are pretty low limits. Like these are not, super production quality renders. They're just, good enough for smaller projects. This did take quite a bit of time to render even with these settings. So if you mess with these, you raise them, it's gonna look better, but you're gonna, your render time's gonna suffer. On camera effects, we have our velocity blur turned on, and that's gonna read those values we wrote out of our sims, those velocity values, and make sure that the fire and the smoke are doing a motion blur. On the image output tab, we've got our render passes, and so we're going to look at these in Nuke in a minute. But basically, we have the beauty pass, and that's going to be split per LPE tag, so we're going to have control over all those lights. We have the direct emission and the indirect emission, which is basically just going to be for us to add some glow and interest to the fire when we comp it. And then for a utility pass, I've got the depth and camera space coming out because we're going to use that for a few things in Nuke, refining the depth of field and also some fog. We also need to make sure that we are outputting an EXR sequence so that we can carry all that data with the render passes in there. A PNG will not carry that data, but an EXR will. And so with that, I just rendered it out, and we're going to jump into Nuke and see what compositing this looked like. All right, over here in Nuke, we have a fairly simple compositing tree. We're going to start bringing in our footage with a read node and making sure to use the right color space that we rendered it out in. I used Aces CG, but you should set this to what you use to render it out in. And from here, we're splitting the footage down into these component parts, these are shuffle nodes. So if you just do tab and shuffle, you will get this node. And in these, we are basically just choosing all of those layers, those LPEs basically that we exported. And we're doing those one at a time so that we can really control how we tune this light. So we've got all these lights separated out here, and we want to merge those over each other with a plus. Plus is important. And then basically to all these, I just did a little bit of grading. So this is just kind of making things brighter, adding a little bit more punch. Nothing crazy here. This is, I did bring the HDRI down quite a bit because I wanted the other lights to be a bigger deal. So that's all I did there, and just merged those all together. And this is going to give us the plate with the smoke but no fire, and we'll do this in the next step. So we want to split off again from that footage pipe, and we're going to do another shuffle node, this time getting the indirect emission, which is basically that inside of the fire stuff. And so that's going to be thrown through a glow node just to give it a little bit of blur and interest. And then we're going to merge that back over the pass itself. And that's going to be just giving our fire a little bit more volume and interest. And then we're going to grade that up a little bit. And that goes into a screen over the footage. So that's kind of the indirect part of that emission. And then with the direct emission, we do exactly the same thing. We're going to add glow to it and then screen it back over itself. And then we're going to screen that back over the fire, and that's what we get. That's just a little way to bump up the fire, make it a little more interesting. From there, we're going to break off again from our footage node, and in this shuffle node, we're going to grab our depth extra, and we're going to route that, which is just a green channel, to alpha. And here, I'm going to basically, this is just normalizing this depth map. So if we look at this, and we go into the channel that it's on, which is depth extra, you just see red here, right? And so if you notice, when I move my mouse, there is actually data here. And if you bump down this exposure thing, you can see what it looks like. It's kind of noisy, right? Because this is not a main pass, but this is our depth pass. And we're going to use this to create a little bit of fog. So you see your mouse moving, like a lot of people say, oh, I don't have any depth data. You do. If you see numbers on at least one channel, that's where your depth is. So if we go back here, so all I'm doing with this node just normalizes that. You don't really need to do that. I just kind of set it up here to have it. And then here we're going to blur that alpha channel because we want to get rid of some of that like crackliness. And this is for fog, so we don't need this to be super sharp here. So we're just going to blur down that alpha, which we shuffled the depth pass into here. So we're blurring only this channel. And then we're basically taking the scene, and if we go back to RGBA here, we're going to blur this scene quite a bit. And we are going to merge this over and use that depth mask to control how much. So you can see that the guy is a little bit less blurry and the stuff in the background is really blurry. So that depth mask is going to give us that sort of depth fog effect. And this is obviously much cheaper to do than rendering it out, especially for a small scene like this, right? Like this is what this looks like. And if I, it's so subtle, but you can see these flames start to glow a little bit, the background lights, there's just a little bit of a haze and things are a little bit more dreamy and ethereal, but this is a very small scene. We could have used the Karma Fog volume, but this is kind of an expensive render already because of the fire. So this is a great way to do this in 2D, save yourself a whole bunch of time. So that's that effect, which I like a lot. I added a little bit of grain. This is sort of modifying the depth of field. And so if I sort of zoom in on the guy's hand here and I disable this node, you can see that his hand is more in focus from the render itself. And I don't know, it kind of bothered me. I just kind of wanted to refine that a little bit. So this Z to focus node is kind of a better option than stuff like blur, where you can actually set the focal point and then we use that depth channel again and just tell it that we want to use that depth extra.z and just sort of refine this, setting the focal point. You can drag this around, setting this roughly where our focal point in the actual image is. It's going to blur just the foreground and be a bit of a natural result. So just taking a little bit of edge off the front there. This blur is going to be our sort of edge of camera, faking that sort of lens blur around the edge. There's just a roto shape here. And so just a little bit more blurring around that little elliptical area there. And we've got a 1.5 pixel blur over the whole thing, again, to take that sort of sharpness out of CG Town and make it a little more natural. And then we crop all this because these operations sometimes result in a little bit of overscan. And we just want to make sure always that we're not rendering a bunch of pixels around this frame because that slows things down quite a bit. And finally, we just write it out to disk as a PNG sequence, and that's our shot. So stay calm, stay cool, set stuff on fire, virtual stuff on fire. Don't set real things on fire. Set things on fire in Houdini. It's a great time. Stay well and see you soon.